These are notes for 3.5 on x and y intercepts. So let's just jump right in. It says the x-intercept, which is also called root, zero, or solution. Those are three terms that are synonymous with x-intercept. However, I will say that we will use these more in the weeks ahead in algebra than with this lesson. Most of the time we're just going to refer to the x-intercept as the x-intercept. But if you see one of these other words, it means the same thing. Anyway, the x-intercept is the point where a graph crosses or intersects the x-axis. So just looking below here, here's on number 1, here is the x-axis right here, and we see this graph of a line here on the graph. If we were to follow the x-axis along here, we can see that the line crosses the x-axis right there, and that would be the x-intercept. Okay, now if the x-intercept is where it crosses the x-axis, what do you think the y-intercept is? The y-intercept is where the graph crosses the y-axis. So your y-axis is right here, it goes up and down, and it's going to cross right there. So we're going to label those, the x-intercept and the y-intercept, and use a coordinate pair. Remember, a coordinate pair is an x, comma, y. And so the x-intercept is over here, and that is 4, comma, 0. And the y-intercept is right here, and that is 0, comma, negative 2. Now, it asks us right here in this call-out box for the slope. So we can find the slope by doing rise over run. We can see that this line has positive slope, so that's 2 over 4, which equals 1/2. Now, you could also figure out the slope even without the graph, because when you have the x and y intercept, when you have 2 points like that, 4, 0, and 0, negative 2, we can always find the change in y. From 0 to negative 2 is down 2, and from 4 to 0 is down 4. So we have negative 2 divided by negative 4, which is positive 2/4, which equals 1/2. So either way, you come up with the same slope. In this case, we did it with a graph, rise over run. Okay, now let's go to the next problem. Okay, so let's look at the second line. Here's the x-axis. Remember, x goes left to right. Here's the y-axis. And we want to find the x and y intercepts. So we're going to look at our line, and we want on the x-axis, this is where the line crosses the x-axis, and that would be at 1, comma, 0. Remember, we're always going to write it as an ordered pair. And then the y-intercept is where it crosses the y-axis, which is right there, and that's 0, comma, 3. And then we want to get the slope. We can see that this line has negative slope. It's going down. So I'm just going to go ahead and put my negative sign there. And so we have a rise over run. Oops, I didn't draw that very well, did I? Rise over run. And we can see that the slope is negative 3 over 1. Or we could write that as negative 3. And again, you can always find your slope by looking at your points. On here, from 0 to 3, we went up 3. That's the change in y. And then the change in x, which is down 1. So it's 3 over negative 1 equals negative 3. So either way, using the graph, rise over run, or just use your points to figure out your slope is negative 3. Okay, so let's take a look at number 3. It's a little bit more unusual. We want to find the x and y intercepts. So where does the graph of the line cross the x-axis? Well, it's right here. And so we would say that's approximately 3.5, comma, 0. Now, what about the y-intercept? Where does this graph cross the y-axis? Well, it doesn't. There is no y-intercept because This is a special line. It's never going to cross the y-axis. And this line for the slope, we can see it's a vertical line, and it's crossing the x-axis. That's an undefined slope. There's the word vux to help us remember that. It has undefined slope. Well, now on the last one, again, a little bit tricky here. Made that a little bigger so we can see it. Okay, so we want to find the x and y intercept. So basically, we're going to have to extend this line right here to see where it crosses the x and y axis. So the best way, most accurate way we could do that would be to find the slope. So it has a rise of 3 and a run of 4. So I can go up 3 and over 4, and there's another point on the line right there. And then we could do it again. A rise of 3 and a run of 4, and there's another point right there. And so, bam. We'll just keep drawing our line. I didn't do a very good job of that. Let's try it again. And that's going to go on forever in both directions. So here's our y-intercept, and here's the x-intercept. So the x-intercept right here is going to be 4, 0. The y-intercept is 0, negative 3. And the slope we already figured out was 3 over 4. Now, there's something I want to point out to you. This is very important. On the first question, we said the x-intercept was 4, 0. On the second one, it was 1, 0. On the fourth one, I'm skipping the third one because it was a special line. But the third one was 4, 0. On the y-intercepts, we had 0, negative 2, 0, 3, and 0, negative 3. So what do you notice that's the same on all the x-intercepts? All the x-intercepts have y equals 0, and that's what's always going to be the case on the x-intercept. The x-intercept, when we write it, the x, remember we have x comma y, the x is going to be the one that has the number, and the y is always going to be 0. The y-intercepts, what do you notice about them? That on all of the y-intercepts, the x is 0. So on the y-intercept, it's the x that's going to have a 0, and the y is going to have a number. It's always going to be true that way for x and y intercepts. So that's going to help us do the next couple questions. Let's take a look. So on number 5, it says identify the x and y intercepts and then the slope from these tables that we have here. So let's look here. Remember, the x-intercept is where y equals 0. So we can look and say, whoops, there it is, right there, negative 3, 0. And then we want to see what the y-intercept is. And the y-intercept is where x equals 0. And so here we go, 0, 5. And now we need to find the slope. And so let's do the change in y over the change in x. From 0 to 5, what's the change in y? Is positive 5 from 0 to 5. From negative 3 up to 0, what's that change? 3. So we have a slope of 5 over 3. Okay, let's look at number 6. Why don't you hit pause and try and figure out the x and y intercepts yourself? Okay, so hopefully you found that the x-intercept was 9, 0. The y-intercept was 0, 6, and then I did the change in y over the change in x to figure out the slope. Now I want you to notice that it doesn't matter which 2 points you pick in the table to get the slope. I just used the intercepts down here to figure out the slope. This was a plus 6 minus 9 and got 2/3. But what if I picked these 2 points right here? Well, the change in y from 4 to 2 is minus 2. The change in x was positive 3. And in both cases, we get negative 2/3 as a slope. Doesn't matter which 2 points you pick. You always get the same slope, as long as you do the math correctly. Okay, now let's look at number 7. Now this one's a little bit trickier because in this one we only have this one point right here, but we were given the slope. Now remember, the slope is the change in y over the change in x. So in this, the slope is going up 5 on y and up 2 on x. So let's just start with the point that we have here. And so when we change the y, we're going to go up 5. So what is negative 5 plus 5? We're going to get 0. And then we're going to go up 5 again. We get 5. And let's go up 5 again, and we get 10. Now what if I wanted to go backwards? Then I start at the negative 5. I'm going to go down negative 5. So negative 5 minus 5 is negative 10 that way. Now let's do the x's. If we start at 4 and go plus 2, negative 4 plus 2 is negative 2. And then we have negative 2 plus 2 is 0. And then this would be positive 2. And if I went backwards, I get negative 6. Now, let's find the x and y intercepts. The x-intercept is where y equals 0. So that would be this right here. So that's going to be negative 2, 0. And then the y-intercept is 0, 5. Right here, where y equals 0, or where x equals 0. X-intercept, the y-intercept is where x equals 0 gives us the y-intercept. Okay, so we're good. Now let's go to the back. Okay, on number 8, we've got a real life problem. So we have the volleyball team is traveling to a game that's 120 miles away. Their average speed is 40 miles per hour. The graph line describes the distance left to travel at any time during the trip. Find x and y intercepts and state what each one represents. Okay, so when we're looking at this, it's important when they start asking us what does it represent or what do the x and y intercepts mean, you're going to have to look at what it says for the x-axis. Remember, this is the x going left to right, and y goes up and down. So left to right is time in hours. I'm going to make this a little bigger so we can see it. And then this distance over here is the number of miles left that they have to travel. So our x and y intercepts are going to be where they cross the x and y axes. So right here is our x-intercept. So that x-intercept is 3, 0. Now, what about the y-intercept? The y-intercept is where it crosses the y-axis, and that's 0, 120. Now it says, what do these mean? Well, the easiest way to figure out what it means is to look at our titles. Remember, a coordinate pair is always x, y. So this 3 is the x, and that's the number of hours. And this would be the number of miles that the team still has left to travel. This is hours, miles. So if I'm telling you what this point means, it's telling you that when they've gone for 3 hours, after 3 hours, there's 0 miles left to travel. I'm going to say 0 miles remain, because they've reached their destination basically. Now, the y-intercept, when they've gone 0 hours, meaning they haven't even started yet, they've gone 0 hours, they still have 120 miles remaining to travel. So basically, that's the total amount of miles they need to drive. This shows you the total amount of hours that it need to take to get to where they were, because we don't have anywhere to go. You're at 0 miles left on this one. At 0 hours, you still have 120 miles to go. Okay, now, these next questions below here, we're going to find x and y intercepts a little different way on these. And this is my suggestion. On equations that are set up like this, we call this standard form, because standard form always has the x term and the y term on the left side, and then the number on the right side. So we say ax plus by equals c. So the x plus the y equals the number that's on the left side. Now, or on the right side. So what I suggest then is when you're trying to find the x-intercept, cover up the y. You can just use your finger, cover it up, and then solve the little problem that's remaining. And then if you want to find the y-intercept, cover up the x. Use your finger, cover up the x, and then solve the little problem that's remaining. So we're going to try that right now. Let's look here. We want to get the x-intercept to begin with. So if we're going to get the x-intercept, let's cover up y. I'm covering it up. And so what's remaining on the problem? It says 1/2 x equals -4. So what's an easy way to solve that? We want to get x by itself. Let's multiply both sides by 2. And x equals -8. Okay, now I'm going to erase that, and we need to find the y-intercept. Well, to find the y-intercept, we're going to cover up the x. Cover it up, and what do we have left over? We have -2y equals -4. So we're going to divide by -2, and we find the y-intercept is y equals +2, because a negative divided by a negative is a positive. So let's write these as coordinate pairs. The x-intercept is going to be -8, 0, and the y-intercept is going to be 0, 2. Now let's go ahead and graph these. So we're going to go -8, 0 right here, and 0, 2, and then use your straight edge. You could use your badge to draw a line, and there it is. Now we also need to find the slope, and how about we do that just using the numbers here. From 0 to 2, we went up +2, and from -8 up to 0, we went up by 8, so we'll reduce that and get 1/4. That's our slope. And we can check to make sure that's right, because if you start here, we can go up 1 and over 4, and there we are on the line. Up 1 over 4, 1 over 4. And you're still on the line every time. Okay? Now let's do the last one. Okay, so here's our problem. We have -4y equals 3x minus 12. Now I'm going to suggest to find the x and y intercepts, let's take this 3x and move it back over and put this into standard form. So I'm going to subtract 3x, and so that's going to be -3x minus 4y equals 12. Okay, now once I have that, I want to find the x-intercept. So to find the x-intercept, I'm going to cover up the y. Use your finger and cover up the y. And what do we have left over? -3x equals 12. Divide by -3. And x equals -4. Okay, now let's go ahead and cover up the y, or cover up the x and find y. So I'm going to rewrite this. So we're trying to find the y-intercept, so let's cover up the x. And so we have -4y equals 12. Divide by -4. X equals -3. So let's write these as coordinate pairs. The x-intercept is -4, 0. The y-intercept is 0, -3. So okay, you know what? I just noticed that I made a mistake, a big mistake, which I hope you noticed. When I put this 12 down here, I've left off the negative sign. So when I did that, this should have been a negative divided by a negative should be positive 4, and this one would have been a negative divided by a negative should be positive 3. Oopsie, so this is plus, this is plus. Now we're in good shape. I hope you were able to catch that. You noticed that I made a mistake. Okay, so the x-intercept is at 4, 0. The y-intercept is at 0, 3. And we can draw this line. And there's the graph and the slope, rise over run. Remember, slope, the slope here is negative. It's going down. So we're going to put a negative sign and rise of 3 over run, and you have a slope of negative 3/4. And you can write that down at the bottom where it says slope. Okay, that's your lesson on x and y intercepts, and we'll see you in class.